hulk verelistakutest on loetud tegelikult punasteks verelibledeks.
We've missed some of the red blood cells.
Ja osad punastest verelibledest on tegelikult loetud siis verelistakuteks.
But the effect will be much less obvious.
Aga palju vähem, palju halvemini ilmneb see siis nendel järgmistel graafikutel.
So you're probably thinking, well, this is very distant and remote from what I do in day-to-day practice. But I want to show you some examples of typical impedance graphs that you'll see in general practice.
See võib tunduda tavapraktiku jaoks ebaolulise jutuna, aga ta näitab konkreetseid näiteid, kus tegelikult on näha, kuidas see mõjutab tavapraktiku elu.
So we are hoping to see two hills, one for the platelets and one for the red blood cells.
Me eeldame, et tekib kaks kuhjakest, ühes on siis punased verelibled ja teises on verelistakud.
It's very hard compared to the number of red blood cells to appreciate the number of platelets. There's usually much fewer.
On väga keeruline võrrelda verelistakute ja punaste vereliblede arvu, sest see arv on väga erineva suurusega.
And so the analyzer will provide a magnification of this area of interest.
Seega seda huvit pakkuvat ala masin suurem.
So please have a look at this first patient here and tell me whether you think the count of platelets is going to be overcounted or undercounted.
Kui vaadata nüüd seda keskmist graafikut, siis ta palub öelda, et kas teile tundub, et verelistakute arv on alahinnatud või ülehinnatud.
Overcounted.
Exactly, overcounted. Here is the line where the analyzer thinks that the platelets start and the red blood cells are on this side. You can see the line has missed the value.
Et tegelikult siis masin on tõmmanud selle eristusjoone valesse kohta, et see eristusjoon peaks olema seal, kus on org kahe künka vahel.
What about in this next patient? We can see the hill for the red blood cells and magnification of that area just here.
Ja siin on järgmine patsient, kus on jälle küsimus, et kas see joon on õiges kohas.
Can anybody guess what has caused this pattern?
Mis võiks olla selle mustri põhjuseks?
It's platelet aggregation.
See on verelistakute omavaheline kokkukleepumine ja agregeerumine.
You will see this in many of your feline patients.
Seda on kassida väga palju.
Because it's not a smooth hill, the analyzer has been confused about where to put this line.
Aga kuna see graafik ei ole nagu sileda pinnaga küngas, siis masin on jälle eksinud selle piiri tõmbamisel.
So do you think the platelet count of the analyzer will be reliable?
Kuidas teile tundub, et kas verelistakute üldarvu määramine on üldse usaldusväärne?
No.
No, we're going to see again overcounting.
Et siin on jälle verelistakuid loetud rohkem, kui need tegelikult on.
Now, most people, when I tell them about this, don't find this particularly interesting, but it is important if you're going to get value for money for your pet owners from doing the hematology.
Paljud inimesed, paljud loomaarstid ei pea seda infot eriti oluliseks, aga tegelikult see on oluline info, kui me mõtleme, mida me oma raha eest saame.
Sorry, from the last graph, did you say that the lowest graph would be overestimated as well?
Probably, because I am guessing that there's one hill here, and this is the start of the red blood cells.
Okay, I see.
And so it's counting red blood cells as platelets. We have an example from a different analyzer.
Siin on nüüd näide ühest teisest masinast.
Again, we have magnification of this area to show us the platelets here.
Samuti verelistakute ala välja suurendatud.
And again, you can see platelet aggregation.
Samuti jälle verelistakute agregeerumine.
It's harder to guess what's wrong in terms of the reported concentration, but I would not trust the platelet concentration from this analyzer.
Ka jälle raske otsustada, mis on mõõtmisel valesti, aga selge on, et verelistatute üldarvu ei saa usaldada.
So the impedance analyzers try to do the same thing with the white blood cells as well, and they're trying to sort the white blood cells by size alone.
Impedance-masinad püüavad sama asja teha siis ka valgete verelibledega ja diferentseerida erinevat tüüpi vereliblesid nende suuruse järgi.
Again, the graphs look complex, but they're not unduly difficult.
Jälle need graafikud näevad keeruliselt välja, kuid tegelikult nad ei ole nii sebased.
Again, we have size of cells on this axis with bigger cells at this end, smaller cells at that end.
Horisontaalteljel on siis rakkude suurus ehk et mida paremale, seda suuremad rakud.
We are trying to divide the white blood cells into three parts: the granulocytes, the monocytes, and the lymphocytes.
Siin on püütud siis jagada valged verelibled suuruse järgi erinevatesse rühmadesse.
In an ideal sample, we would have 3 hills with 2 valleys, and it would be easy for the analyzer to put the straight lines.
Ideaalses proovis tekiks siis 3 küngast, millel on selged vahed omavahel, ehk et me saaksime eristada 3 tüüpi rakke.
But this is the typical experience of a vet using an impedance analyzer on an unwell canine sample.
See väike pilt näitaks tüüpilist tulemust impedance-masinaga, kui loomaarst püüab määrata valgete vereliblede hulka.
Remember, we are looking for 3 hills, 2 valleys. Here you can only see 2 hills. Maybe there's an extra hill there. I don't know. But both lines have been placed in the middle of that one valley.
Tüüpiliselt me siis otsiksime 3 tõusu 3 küngast 2 vahekohaga, mis siin tegelikult on 2 küngast. Kus on see 3. ei tea, jooned on suvalisse kohta pandud.
Essentially you're looking for a hill for each part of the differential.
Tüüpiliselt peaksime siis otsima 3 tõusu, mis igaüks peegeldab siis eraldi rakku tüüpi.
But it's near impossible to sort out white blood cells by size alone when there is significant pathology.
Kuid kui on tegu olulise patoloogiaga, siis on väga raske valgeid vereliblesid üksteisest suuruse järgi eristada.
The impedance analyzers work sorting by size alone, and theoretically all those things would be exactly the same.
Impedance-masinad eristavad rakke suuruse järgi ja ideaalselt peaks see asi töötama, rakke peaks olema võimalik suuruse järgi eristada.
So more recently, hematology analyzers have been based around a laser, and I suspect you won't be excited to see the insides of a laser-based analyzer.
Uuemad masinad põhinevad lasertehnoloogial ja ta arvab, et meid väga ei huvita see, mis seal masina sees tegelikult on.
But the point that you need to appreciate is not how the technology works, that we're measuring a variety of different features of the cells.
Kuid oluline oleks siis mitte aru saada sellest, kuidas see tegelikult töötab, vaid selles, et ta kasutab erinevaid viise eristamaks rakutüüpe omavahel, mitte ainult suurust.
So the cells flow past the laser and the sensors detect a variety of features of the cells.
Rakud liikuvad laserkiirest läbi ja hinnatakse siis raku erinevaid parameetreid.
So let us look at the red cell dot plot, similar to the one we were looking at earlier.
Siin on siis punaste vereliblede dot plot.
On this particular analyzer, and this could be any analyzer, we have size on the vertical axis.
Sellel konkreetsel masinal on siis raku suurus vertikaalteljel.
So large cells, small cells, then we have fluorescence on the horizontal axis.
Suuremad rakud kõrgemal, väiksed madalamal ja horisontaalteljel on siis nende helendus, fluoressents.
And you remember earlier that we saw that the youngest reticulocytes were furthest out because they will fluoresce more when struck by the laser.
ja nooremad retikulotsüüdid helendavad rohkem, ehk nad on siis selle teljel rohkem paremal.
So if we have a patient, we can see it has lots of reticulocytes. Which cloud, A or B, would we expect to move first if this patient developed an iron deficiency today?
Kui patsiendil tekkis täna rauapuudus, aneemia, millist rakkukogumit me eeldame, et ta liiguks esimesena? A või B?
Which cloud will move first? Sorry?
B left.
B. These are the ones that have just been made. Remember, young cells fluoresce more.
B on siis rakkude grupp, mis on just hiljuti välja tulnud luuidist.
A is the cloud of older red blood cells.
Ja A on grupp, mille moodustavad vanemad punased verelibled.
So we would expect B to move first.
Ja me eeldame siis tegelikult rühm B liigub esimesena.
So these are reports from different analyzers.
Need on erinevad analüsaatorite graafikud.
Here we have a lot of reticulocytes from a busy bone marrow.
Palju retikulotsüüte.
Ignore the fact that the color background is different on this one, but what do you think to the reticulocytes from this patient?
Aga see taust on küll erinevat värvi, aga mida te ütlete selle patsiendi ja tema retikulotsüütide kohta parempoolsed pildid? Smaller.
Smaller. They're much smaller. You can see how quick and easy it is to spot. So what would we do for that patient? It's probably got iron deficiency.
Mida me arvame selle patsiendi kohta, mis me teeme temaga? Ta on tõenäoliselt rauavaegus aneemia.
It's a simple case of trying to get more iron into that patient if we can. Oftentimes it's as simple as persuading the patient to eat.
Et sellise patsiendi puhul peaks siis püüdma talle manustada rohkem rauda, ehk siis lihtsalt rohkem süüa.
So let us have a look at another patient here. This is a patient called Gio.
Siin on patsient, kelle nimi on Gio ja siin on tema veri.
So if we compare him to normal, you can see that he's had smaller red blood cells for some time.
Ja siin on näha, kui võrrelda normaalse pildiga, et sellel Giol on olnud juba mõnda aega vererakud väiksemad.
And if you look at the output from his factory today, the bone marrow is making small red blood cells.
Ja tema luuüdist tulevad välja pisikesed verelibled.
But I want you to look at another feature on this report, which is the platelet concentration.
Ja ta juhib tähelepanu verelistakute kontsentratsioonile.
What do you notice about the reported platelet concentration?
Mis torkab silma?
So there are two things to notice. First, that the reported concentration is very low.
Sellel arvuline väärtus näitab, et see on väga madal.
But can you see there's an asterisk on the report?
Aga seal on tärn ees.
Now it varies by analyzers, but there's a general rule in hematology. If you see an asterisk, it's further encouragement to look at the dot plots below.
Ehk et väga paljudel analüsaatoritel see tärn tähendab seda, et sa peaksid vaatama seda graafilist kujutust, seda dotplotti.
So far we've met the red dots, which are the mature red blood cells, and the purple dots that are the reticulocytes.
Et selled punased on siis täiskasvanud punased verelibled ja roosad lillakad on retikulotsüüdid noored.
But we've yet to meet the platelets, which are shown in blue.
Ja verelistakud on näidatud sinisena.
So here we have our normal patient, and this is a normal density of platelets.
Parempoolsel on siis normaalse patsiendi veri ja verelistakute normaalne tihedus.
What do you think to the concentration of platelets for Gio?
Ja kuidas teile tundub selle Gio verelistakute kontsentratsioon?
Yeah. And that's in direct contradiction to the number that we see up above.
Need on palju rohkem, mis on siis otseselt vastuolus selle numbriliselt kujutatud tulemusega.
So the typical response of a vet to see a low platelet concentration on whatever analyzer they're using is to say, oh, what an awful analyzer.
Et kui ükskõik missuguse analüsaatori puhul loomast näeb seda madalat tulemust, ütleb, et analüsaator on halb.
But what the analyzer is encouraging you to do is to look at the graphical report.
Aga mida analüsaator tegelikult teeb, on see, et ta ütleb, et vaata seda graafilist kujutist.
And you can quickly see that there are plenty of platelets.
Ja sa näed kohe, et tegelikult need verelükakud on palju.
I know this is not an exciting topic, but if we're going to do hematology, we need to understand all of the reports.
Et see ei ole kindlasti väga huvitav, kui me läheme edasi, et näeme seda tähtsust.
So we look again now at the white blood cell dot plot.
Valgete verelükkade graafiline kujutus.
It varies by which analyzer you have, but they all use the same principle.
Varieerub sõltuvalt analüsaatorist, aga põhimõte, kujutamispõhimõte on üldiselt kõige sama.
Each dot represents a cell, and the dots come together to make clouds or clusters.
Iga täht tähistab ühte rakku ja nad koonduvad siis kogumitesse, pilvetustesse.
So here we have the neutrophils. Now we regard the neutrophils as being, and this is a simplification, a relatively mature population of white blood cells.
Et seda värvi pilvekene siin sellel konkreetsel näitab siis neutrofiile, suhteliselt vanu neutrofiile.
We also have eosinophils. Eosinophils are more granular, more lumpy, bumpy, and are found further over on this axis.
Ja see järgmine kogum näitab eosinofiile, mis siis rohkem granulaarsed, rohkem sellised ebaotsesed.
We have the lymphocytes in blue. These can further differentiate into T cells and B cells. They have more RNA in their cytoplasm. They're less mature, if you will, than the neutrophils. They're found higher up this axis.
Ja siin on leukotsüütide pilvekene, nooremad on kõrgemal ja on analüsaatorid, mis võimaldavad ka eristada erinevat tüüpi leukotsüüte.
Finally, we have the monocytes. Those go on to become macrophages or Langhans cells. The least mature of the white blood cells, if you forgive the simplification, found highest on the graph.
Ja kõige üleval on siis monotsüüdid, erinevat tüüpi monotsüüdid.
We'll come to the orange cloud later.
Oranžist on hiljem juttu.
So let us look at this white blood cell dot plot. Here we've got the normal with separate clouds for each of the white blood cells.
Vasakpoolne on siis normaalne veri, koera normaalne veri, kus erinevad valged verelükkad moodustavad selgelt eristatava kogumi.
Let's compare that to our patient on the right. You can see in the normal, the neutrophils is relatively low, but it's shifted a little bit higher here.
Ja patoloogiga patsiendi paremal pool on neutrofiilide kogum kerkinud kõrgemalt ja muutunud nooremaks.
Remember, the fluorescence axis is a measure, if you will, of the maturity of the cells, least mature, most mature.
See fluoressentsi teid näitab rakkude vanust.
But that's a relatively mild change compared to what's happened to the lymphocytes. Can you see how the lymphocytes have moved upwards?
Kuid see neutrofiilide muutus on suhteliselt mõõdukas võrreldes lümfotsüütide muutusega, nad on oluliselt kõrgemale tõusnud.
Do you think this cell is really a monocyte, as the analyzer thinks?
Ja mis te arvate, kas see, mida ta osutas, et kas see tegelikult on monotsüüt, nii nagu analüsaator arvab?
Absolutely not.
Kindlasti mitte.
This is why people are sometimes frustrated with hematology, because they look at the reported numbers and they don't look at the graphical reports.
Ja see on ka üks põhjus, miks hematoloogia sageli inimesi frustreerib, et nad vaatavad ainult numbreid, kui nad ei vaata seda graafilist kujutust.
We can see we have a huge population of immature lymphocytes that is spread upwards.
Me näeme tegelikult, et sellel loomal on tohutu populatsioon noori lümfotsüüte, kujutis kerkib üles.
expected, guessed already, we had a lymphoid leukemia.
Ja nagu te võisite isegi arvata, patsiendil on lümfoidne leukeemia.
So when we have immature cells, they spread along the fluorescence axis.
Kui meil on tegu noorte rakkudega, siis need jagunevad laiali, kerkivad üles selle fluoressentsi teljel.
So we saw this earlier, when we have a left shift, the cells spread upwards, and you can see now how the neutrophil population is indistinguishable from the lymphocyte population.
Vasaknihkega neutrofiilide pilvekene venib välja ülespoole ja tegelikult neutrofiilide ja lümfotsüütide kogumid on oma üksteisest eristamatud.
You can appreciate why the analyzer marks stars against the report, because it's been unable to distinguish one population from another.
Taas on nähtav, miks arvulises väljenduses kasutatakse tärne, ehk et masin tegelikult ei suuda erinevat tüüpi rakke üksteisest eristada.
So we're now going to look at a time sequence of dot plots to see how it might potentially help our patients.
Ja siin me näeme muutust ajas ja kuidas graafiline kujutus võiks meie patsiente aidata.
So we have 4 dot plots, each from 12 hours apart.
Siin on nüüd 4 graafilist kujutust dotplotti, mis igaüks erinevad 12 tunni võrra.
Remember, the life expectancy in health for a neutrophil might be 8 to 10 hours.
Et neutrofiili eluiga on 8 kuni 12 tundi.
So in this first sample, remember, if we have overlapping clouds, the analyzer has not been able to distinguish one population from another.
Et kui meil on 11 katvad pilved, siis masin ei ole suutnud eristada üht rakutüüpi teisest.
Will the numbers that come out of the analyzer be correct?
Kas need numbrid, mis tulevad analüsaatorist välja, kas need on korrektsed?
No, the numbers are going to be wrong. Do we need numbers?
Numbrid on ilmselgelt valed ja kas meil on neid numbreid vaja?
We probably don't need numbers because we can see we've got a lot of immature neutrophils.
Meil tõenäoliselt neid numbreid tegelikult vaja ei ole, sest me näeme, et meil on veres palju noori neutrofiile.
If we worked in a university, we would probably do a manual differential.
Kui me oleks ülikoolis, siis me ilmselt teeksime manuaalse eristuse.
But for real life practice, I can see that I've got an inflammatory situation that I need to control.
Kui praksises me näeme, et tegemist on põletikuga ja ma pean sellega tegelema.
So I liken these young neutrophils to child soldiers that are being used in a time of crisis.
Need noored neutrofiilid, need on nagu lapssõdurid, kes on aetud välja kriisikoldes võitlema.
So here we are using lots of child soldiers. Here, no.
Ehk et seal, kus on 0 esimene vereproov, seal on neid noori neutrofiile lapssõdureid väga palju ja 36 tunni pärast neid praktiliselt enam ei ole.
So this patient had an inflammatory situation brought about by infection, which we were controlling with a variety of antibiotics and non-steroidals. The patient in its cage over these 36 hours was recumbent under the influence of opioids. There was no obvious clinical change from the start to the finish.
Patsiendil oli tugev põletiku reaktsioon, millest raviti erinevate antibiootikumide ja ensaididega. Kuna ta sai opioide, siis ta oli seal oma puuris 36 tunni jooksul sisuliselt lapiti maas, et kliiniliselt me ei näe erilist paranemist.
But with regard to the inflammatory situation, is the dog getting better or is the dog getting worse?
Kuid kas vereanalüüsi põhinevalt võime me öelda, kas see olukord läheb paremaks või halvemaks?
Better.
Dog's getting better. Using a lot of child soldiers, fewer, no child soldiers.
Ehk et põletiku situatsioon läheb järjest paremaks.
So you can see how much you are missing by not looking at the graphical report.
Ta püüab siis näidata, kui palju just me ilma jääme, kui me ei vaata neid graafilisi kujutusi.
So remember, with the graphical reports, you spend no longer than 10 seconds looking at them.
Vaadates seda pilti, me vaatame seda võib-olla rohkem, kõige rohkem 10 sekundit.
And you were asking the question, are the clouds well separated? So here, I would say that cloud is well separated from that cloud. And although those clouds are close, they're not on top of each other.
Peamiselt me küsime, et kas need rakukogumite pilvekesed on üksteisest hästi eraldatud ja seda me näeme kohe.
So the red cell differential is good.
See tähendab, et punaste vereliblede eristus on väga hea.
What about the white blood cell differential? Are we happy with the numbers?
Aga kuidas on valgete vereliblede diferentseerimisega, kus me oleme rahul nende numbritega?
We have not separated the purple from the blue from the red.
Et lilla, sinine ja punane ei ole tegelikult eristatavad üksteisest.
So we look to the stars and we understand why they're marked with an asterisk.
Ja kui me vaatame neid numbreid, siis me saame ja ühtlasi ka pilti, siis me näeme, miks nende numbrite ees on tärnid.
If you compared the numbers with a manual differential, you would have and you would expect to have very different results.
Kui sa võrdled neid numbreid käsitsi tehtud eristuse diferentsiaaliga, siis tegelikult on näha, et need numbrid on väga erinevad. See peakski nii olema.
But again, we have a sequence of dot plots from a different analyzer this time, but it's the same principle. You can see how the clouds of cells are changing.
Siin on samuti nüüd erineva masinaga, kuid samamoodi aeg teedele paigutatud erinevad analüüsid. Me näeme, kuidas situatsioon muutub.
Is the dog's inflammatory situation getting better or is it getting worse?
Kas põletiku seisund koeral muutub paremaks või halvemaks?
We're seeing a lot of child soldiers and the purple doesn't spread up so high. It returns nearly to normal. I would say that dog's inflammatory situation is getting markedly better.
Alguses on näha palju lapssõdureid ja tegelikult pilved katavad üksteist. Hiljem neutrofiilide pilvetena muutub juba peaaegu normaalseks.
So it's challenging to meet a new subject when there's apparently a lot of complexity. However, you very quickly learn when looking at these graphical reports that they become familiar and you quickly spot the abnormalities.
Alguses see teema on inimeste jaoks keeruline, kuid natukene süvenedes on näha, kuidas seda probleemina on võimalik kiiresti sõrm peale panna.
Hopefully you've appreciated that all hematology analyzers have these sort of graphics, but how much information you can get from them.
Ja kõikidel analüsaatoritel graafikud on tegelikult olemas ja sisaldavad väga palju infot.
Very good. So thank you for your time. I'd welcome any questions.
Aitäh ja kas teil on küsimusi?
So this time after lunch, I really will be back with angiospondylosis, which, trust me, is a much easier subject and not as complex as hematology.
Lõuna ja angiospondyloos järgneb pärast, mis lubatakse olevat lihtsam.